All right, so it is day 10 of the term, and it is Tuesday, April 8th. And for your do now today, I just gave you two linear equations, and I wanted you to graph them. So we've been doing this for the last 3 class periods now, so we're going to be moving on to some other things here pretty soon, but let's review this today. Number 1. I'm going to rewrite the problem on my separate paper. We have y equals negative 2 over 3 x plus 4. So when we want to graph a linear equation, we're looking for two things first. Two things need to be identified. Does anybody know the name of the first thing? Slope is 1. What is our slope?
2.
Negative 2 over 3 is our slope. It's always going to be the number next to x. So that's our slope. And what's the other thing we need to find?
Y-intercept.
Y-intercept. What's our y-intercept? Positive 4. So that's our y-intercept. Now to graph this, we just have 3 easy steps. What is step 1? We're going to graph our y-intercept. We'll find 4 on the x or y-axis. Y. You did it correctly. It's easy to say it wrong though. That's okay. So 4 is our y-intercept. That's where the line touches the y-axis. So 4, that's our starting point. Now, what's step 2?
Go up 2.
Down 2. Yep.
Down 2.
So we're going to use our slope for step 2. Since our slope is negative 2 over 3, that means our rise, or how far up or down we go, is negative 2. Since our rise is negative 2, do I go up or down?
Down.
Down. So I'm going to go from my first point down 1, 2.
Over 3.
Yep, and then my 3 is the run. So we go over 3 to the right. 1, 2, 3. And that is my second point. So what's step 3? Connect the dots. And you will need a ruler. If there are not enough rulers at anyone's tables, over underneath the turn-in trays, there are tons more rulers. So feel free to grab more if you want another or something. So I'm just going to line that up as nicely as I can and trace a line. And what is my line missing?
The arrows.
The arrows. You need to put arrows on the ends of your line. Why?
Your answer is not complete without them.
Yes, your answer is not complete without the arrows. The arrows tell us that this line will continue on forever and ever and ever and ever. It's infinite. So we need the arrows. Okay, that is number 1. Do we have any questions about number 1?
Our points.
Okay, yeah, let's label our coordinates. I didn't ask you to do this, but it's great practice. So we want to label this point. What's our x value? 0. And our y? 4. Perfect. Now let's label this coordinate. What's our x? 3. And our y is 2. Good. Good. Now, do we...
Can you read this?
Yes. So, let's look at the first one. And I'm going to use some colors. So, for our first point, the x value is where does this point line up with the x-axis? And it lines up right in between -1 and +1. So it lines up with 0.
That would help out a lot of people too, if they had to
Yes.
right there.
Yes, and you know what? If it helps, you can draw a little 0 in the middle. And then our y value, let's get my blue. Where is my blue? There it is. The y value is just where does the point touch, or where does it line up with the y-axis? And since it's touching 4 on the y-axis, 4 is our y value. So now let's look at this point. I'm seeing this is the x-axis. This point lines up with the x-axis at 3. So that's where our x value came from. And the y value, we want to line up with the y-axis. So I'm going to trace over, and it lines up with 2 for the y. Does that help out a little bit?
No.
Okay, good. Good, good, good. Any other questions? Okay. Are we ready to try the second one? Let me rewrite the second one. We have y equals 5x minus 4. Okay. So, what is my first step?
Negative 4.
-4. Now, what is -4? Like, what do I name this? Yes, the y-intercept. So, where is my starting point?
Your point, -4.
-4. On which axis?
The y.
The y-axis. So, my y goes up and down. I will find -4. There we go.
That's 5.
Yes, now we'll use our slope. Now here's something tricky. This is a tricky part. When our slope is a whole number, when it's not a fraction, we need our slope to be broken up into a rise and a run. So let's do this. Rise, run, and my slope is 5. So I know my rise is 5, but what will my run be? 1. Why is my run gonna be 1?
Because you have to go over 1 for it to rise up.
Yes, I will end up having to go over 1 so that it's not just a straight up and down line.
Yeah.
A whole number to be a fraction, you gotta put a 1 on it.
Yes. In order to make our whole number into a fraction, we put it over 1 every time. So if it's not a fraction, every time your run will be 1, no matter what. So if our rise is 5, we're going to go from here up 5. So 1, 2, 3, 4, 5, and over 1 to the right. 1. That's our next point. Okay. What's step 3?
Make your line with the arrow.
Connect the dots, make your line, add your arrows, all of that good stuff. Okay. Okay. There we go.
And your place would be 1 and 1.
Yes, so now we'll name our coordinates. And let's actually start with the y-intercept. What is the coordinate for the y-intercept here? 0 is our x.
-4.
-4 is our y. Something you might notice is that every time we write the coordinate for the y-intercept, your x is always going to be 0 because it's touching the y-axis, so it's not over to the right or left any. And we'll talk more about that later on too.
And that was simple. That's 1 and 1.
Yeah, and then this point here is 1 and 1 because
They really don't even matter which way you let it.
Yep. It don't matter. We just know that it lines up with 1 on the x-axis and 1 on the y-axis. We see that here. Okay. So that's our second line. Very nice, guys. Very nice. Okay, and I see some of us are still copying that down, so I'm going to give us a minute to finish. I'll pause this. We are going to go ahead and move forward, and I am going to be taking notes on one of these pages. That way I don't have to draw the graph a million times. So again, if you need any graph paper, there's lots on the wooden table up front. And I'm going to start by titling my page Algebra 1, Unit 2. And this is day 10 notes. And we'll call this page 1. So if you were here on Thursday, this may be a familiar lesson. I only gave you a little sneak peek of it on Thursday, but we have been going from seeing an equation and then graphing the line. Now we're going to go backwards. I'm going to give you a line, and we're going to make sure we know how to write the equation. I know, it sounds scary, but it's not too bad. So one thing to note, and I'm going to write this on a sticky note so that I can move it around my paper. You all should have sticky notes at your tables. If for some reason any of the tables don't have a pad of notes, let me know. I have some extras I can hand out. And we are going to write y equals m, and I'm going to use colors, x plus b. And I just want to have this with me as we do this process because it's going to make things easier for us to look back at it than having to flip through pages. I can just stick it on the problem I'm working on. Okay, so this is our linear equation format, meaning every time we have a linear equation, you're going to have y equals, and then there will be a number instead of m for slope. There will be an x, and there will be plus or minus another number. So I'm going to move this just slightly to the side so I have a graph that is free and open. And we are going to draw a line without a formula and see if we can come up with the formula ourselves. So I want us to start with our pens or pencils and make a point on 5 on the y-axis. 5 on the y-axis. That's going to be our first point. What would this coordinate be? 0 for my x. Good. 5 is my y. And next, I'm going to make a point right here on the x-axis at positive 2. Now, what would this coordinate be?
0, 2.
0. Backwards. Yes, 2 is my x. And since we're not going up or down, my y is 0. If I lined up with the y-axis, it lands at 0. I'm going to do that in the middle of my graph, just to remind ourselves that that is 0 in the middle. Okay? And once we have these 2 points, let's connect our dots. And we're going to talk about how to find the equation. Okay, so we have a line. So once we've got this line drawn, that's all right. I'll give everybody a minute. I know sometimes that takes a second. I'll pause. All right. So we have a line. There are two things that we need. Yes.
I'm just waiting for you to get done.
Oh, okay. That's okay. So whenever we're graphing a line, there's two things we look for in the equation. We look for the y-intercept and the slope. When we are writing an equation, we're looking at the same two things, a y-intercept and a slope. So the y-intercept, or b, is just where the line is touching the y-axis. And it's touching at 5, right? So that's the first thing we're going to find out is our y-intercept. So under my graph, I'm going to write b equals 5 because that's our y-intercept. That is where we touch the y-axis at 5. And gosh, guys, you know I'm a big fan of colors. If labeling your axes with colors helps, do it. So I'm going to make my y blue, and I don't have a red highlighter, but I got a pink one. My X is pink. Okay. So you can see that point is touching the blue line, the y-axis, and it's touching it at 5. So my y-intercept is 5. My b is 5. Oh, so I have copies of this up at the front of the room. And we just drew this line on here. Yes, either of those work. Perfect. All right, so I found my y-intercept.
It's gonna be a negative number because it's going down.
What will be a negative number?
Your slope.
You're right. So once we find our y-intercept, we need to find our slope next. Okay, so our slope can also be written as rise over run. Rise meaning whether we go up or down, and run always to the right. So starting from the y-intercept, to get to my next point, would I move up or down? Down.
Going down 6.
So we're going to count, yes, we're going to count how far down we go with our slope. So to do that, I'm going to do just like when we graph it. I'm going to count 1, 2, 3, 4, 5. So my rise is what?
-5.
It's -5 since we went down 5. Okay? And
Your run's gonna be 2.
my run will be 2. So how do you find the run from here?
2.
You're just going to start right here, now that you're at the same height as my second point, and I'm going to count 1, 2. So my run is 2. So we started at the y-intercept and we counted how many spaces do I need to go until I'm at the same height as my next point. Then I counted how far over do I need to go to get to the next point. 2. So if my rise, I'll zoom in a little here. If my rise is -5 and my run is 2, what is my slope?
-5.
It's just -5 over 2. And slope we label as m. Now I'm showing you this fast just because I'm going to next break it down and we're going to do it more slow. And we'll take some notes and write out the steps. So this is more so the demonstration part of things. If you're a little lost, no need to worry yet. We will go over this in detail. So we found our y-intercept, or b, and it was 5. We found our slope, and it was negative 5 over 2. So here's how we put that into an equation. Now, in my equation, we're going to write y equals. What's my slope? That's what comes next. Negative 5 over 2. What comes next? X
Positive 5.
plus my y-intercept, which we found out is 5. You just wrote an equation. That's not so scary when we break it down and do it slowly. Now this admittedly was a little quick. We ran through this fast. If you get it on the first go, awesome. You are ahead of the game. If not, do not worry. We're going to do it slower. Okay. So I'll give everyone a moment because I just wrote a lot of things up here. All right. So here's what we will do now. For some reason, when I write words and numbers on graph paper, I have a harder time seeing it than lined. So I'm going to switch back to lined paper for a minute when we take these notes. And we'll just reference the graph paper. We'll look at it. So we'll call this page 2. And I'm going to start by titling it. And we're going to write out the steps. Algebra 1. We're in Unit 2. And Day 10 notes. And page 2. Okay, so we will title this How to Write a Linear Equation. How to write a linear equation. And that is in y equals x. Is that the last notebook?
Yeah.
Okay, I'm going to restock those. No, take it, absolutely. Yes, girl, that is what they're here for. They're here for you. Oh, it's okay, no problem. All right, so how to write a linear equation. Let's break it down. So, step 1. We want to identify the y-intercept. Or B. And in case we forget that, maybe we're looking back at our notes and like, what on earth is a y-intercept? Somebody remind me, what is a y-intercept? What's that mean? Separate. It's different from slope.
The starting point.
It's the starting point. Which axis does it touch?
The
The y-axis. The y-intercept is where does my line touch the y-axis? Not where does it line up with it, but where does it actually touch? Where does it cross through the y-axis? So, I'm going to write something about that. I'll say, where does the line, wow, I can't spell, touch the y-axis? And that's the one that goes up and down. Okay. And I might get a little arts and craftsy with my notes today. I think I might actually cut one of these graphs out and tape it onto my paper, just so that it's kind of all together. If that's something you want to do as well, just because I know when I was in school, I was somebody like my notes had to match the teacher's. Not that I'm looking at your notes, but if you are wanting to do something similar, I believe there are scissors up at the front of the room too. And there should be tape over here by the turn-in bin. I think I do. Maybe down there. Trisha might have borrowed them, but I can't remember. I should have glue though. So I'm cutting this out real quick because I want to use this for my example. There's scissors up there and glue sticks? Awesome. So I'm cutting out a piece of a graph just so that I can use it as part of my notes, because I don't want to try to draw it on lined paper. Okay. I'll quit it. So I'll wait to actually put this on my paper. But first we identify the y-intercept. And I'm going to draw a line for us to kind of reference. Let's do one here and here. And I will label my lines, or my points. Okay. Okay, so in our example, we're going to write the equation of this line. And I'll give you points too. What's this coordinate?
0, 2.
0, 2. What's this one? Negative 2. No. Negative 2. Negative 3. God. Okay. Oh, do you need more graph paper? So I have, okay, perfect. If you want your notes to look like mine, I have lots of scissors up at the front of the room. I literally just cut it out of my paper and I've got it right here.
I was trying to
Yeah, you're fine, you're
do something
fine.
else.
Yeah, so if anybody wants scissors, I'll say it again. There are scissors up at the front of the room. It should be on the bottom shelf in one of those kind of beige colored bins. And there's lots of pairs. They're adult size. And then Angela, if you wanted one that already has the graphs on it, yes, I made copies up here for you guys. Okay, so let me give everybody a minute to get settled. Let's just get the second step written down as well. So we find the y-intercept, our b. What is the next thing we do?
And the y-intercept.
We just found the y-intercept. What's the other thing?
Oh, you find your slope.
Yes. Now we identify the slope. And we do that by counting spaces. And sometimes that is a little trickier said than done. So we'll go over that lots today. Identify the slope. Let me move that. That's our M. And then we'll write more detailed instructions underneath that. Now to find the slope, I know on the first problem that I showed you, we did start from the y-intercept. Like here, we started from the y-intercept, counted down and counted over. The reason for that was because the slope was, or the y-intercept was coming from the left side of the graph. Basically in math, we like to do things from left to right, the way that we read. I read identify, then slope. That's left to right. Whenever we are reading a graph or a math problem, we're also going to go left to right. So even though we just found, or we would eventually find our y-intercept here, when we count the slope, we want to start from the point that is the farthest left. So we would start with this point. Okay, so to find the slope, we will count from one point of the line and see how many spaces do I rise up to be on the same level as the next point closest to it. Let's see. So if we did this one, 1, 2, 3, 4, 5, it would be 5, yes. Now we'll get to that here in just a minute. I'm trying to think of how could I word this so that it's not too wordy. So count the rise and the run from one point to another. Does that sound simple enough? Okay. So to identify the slope, we will choose 2 points. And we will count the rise and the run from left to right. Okay. So that's step 2, is finding the slope. And we're just kind of writing out the instructions. Then we'll do this for real with this graph I made. Okay. And the third step is once you've done those 2 things, we're going to quote-unquote plug in or replace the values in our equation. So plug in the numbers you found for slope and y-intercept. And that'll be y equals, there will be a number that we put here. And I'm going to write rise over run. That's our slope. X plus our B, or our y-intercept. So just a couple of different ways to think of it. M, B. Okay. So the only thing that will stay the same is the x and the y and the x. Okay. And again, lots of words. I'll pause again, let everybody get this written, and then we will put this into practice. Okay. So let's use these 3 steps, and let's look at this line I've drawn. Okay. Step 1 is we're finding the y-intercept. Now, I want you guys, instead of shouting out answers, because I know some people are like getting it right away, and then some of us, it takes a little bit longer. So let's raise our hands, and I want to try to call on some people that haven't answered as much. how are we going to find our y-intercept? Identify the y-intercept? Yes. How do we find that y-intercept? Somebody raise your hand if you think you know what it is. Angela?
2.
2. How'd you know?
Because it's on the slope.
Because it's on the slope. Let's think about it. It's on, the y-intercept is on that y-axis. Yes. And it is 2. You are correct. It is where our line touches the y-axis. The y being the one that goes up and down. So, step 1 is done. Our y-intercept is here. Or B. And it's 2. Perfect. Now, for the slope, we only have 2 points, and we want to count from the left point to the right point. Now, slope is rise over run, so we'll start from here, and I want to see, to get to this next point, for my rise, will I go down or will I go up? You're going to go up. So, let's see how many spaces that is. 1, 2, 3, 4, 5. We went up 5. So that's my rise. Is it positive or negative? Positive. Why is this positive 5? And not negative? Yes, because we went up. If we had went down, it would be negative. But since we went up, it's positive. And that's why it's going to be important to start on the left point, because if I started on the right, I would have gone down 5. But then I would have went left 2, which would have given me another negative and cancel out. But that's a whole nother lesson. We won't get into that today. So our rise is 5. What else do I need? I need a run. So to count my run, I'm going to start from where I left off and 2 over. I'll go over 1, 2. Good. So my run is 2. Good. So if my rise is 5 and my run is 2, that's my slope, 5 over 2. Okay. So we found the slope, we found the y-intercept. We can write an equation. So I'm going to move this over to the side just a little bit. Our y-intercept is 2. Our slope is 5 over 2. So what is our equation?
Y equals
Yep, y equals 5 over 2.
X plus 2.
X plus 2. That's it. Look at that. It looks crazy. I bet y'all would have seen this and thought, I can't do that. But we just did it. It's right. You break it down into little baby steps and it's not so bad. We just do it slowly, one thing at a time. It'll start feeling like easy.
Easy peasy.
That's right. Okay. Now, something that I have noticed with no student in particular, there's no specific person that I think is doing this, but I have found that when someone is confused, they are also scared to tell me that. again, no one in particular. So to get around that, I want to ask everyone in the class, whether you get it or not, I want you guys to try to come up with one good question that you think would be helpful to somebody else in this room. So let's look at everything we just did, and I'll give you a minute to think, and I would like at least 3 people to ask me a question about what we just did. Even if you get it 100%, you don't need to ask a question. Try to come up with something that you think would help a classmate. Okay, so I'll give you a minute to think about it. If you think you have a question ready, just raise your hand and I'll answer you. Let's think of some questions. Yes, Shayna.
Okay, so with the rise and the run, and you said start from the left and go to the right.
Yes.
Is it always going to be that way? We're always going to go up and over, or are there other instances where we wouldn't have to go down?
Yes, that is a wonderful question. So, Shayna wanted to know, will you always go up and over, or are there instances where we might go down? The answer is yes, there are times where we might go down. For instance, like this problem that we did right before this. From left to right, our first point, we had to go down to get to the second point. And that is when we would get a negative slope.
Okay.
Yes. So it depends on which way your line is facing. And something else to notice is, let's say you don't put -5 as your rise here. You counted the 5 and the 2, and you're like, okay, my slope is 5/2. Do you see how these 2 lines have the same numbers for slope, but one is positive, one is negative? This one is positive 5/2. This one is negative 5/2.
You just doing opposite.
Yeah, we're just doing the opposite. These lines don't look the same. Even though they have the same numbers, the difference is the way that they're facing. This line from left to right goes uphill, goes up, so it's positive. This line, if we're going from left to right, goes downhill. When your line goes downhill,
You're going to the next.
it's going to be a negative slope every single time. Your slope will be negative when that line goes down. So if you're worried about remembering the signs, whether it's a positive or negative rise, you can also just look at, how does your line look? What direction is it going? Is it going up? It's positive. Is it going down? It's negative. So that might be a nice thing to add in as a note down here about slope. So slope, I'm going to say this is what a positive slope looks like.
Yeah, that ain't about watch it.
Yeah. This is what a negative slope will look like.
See you tomorrow.
See ya. Have a good day. Okay. So that's something that might be helpful. And that was a great question, Shayna. Thank you. Okay, I want 2 more questions. Even if you get it, come up with something that you think might help someone else. 2 more questions.
Okay,
Yes.
I'm writing the equation. So, is it the y-intercept that's gonna always come first, and then it's the, I know what I wanna say, I can't get that.
The slope?
Yes.
Yes. So whenever we're actually writing the equation, like we're given the line and we're supposed to come up with the equation, technically it doesn't necessarily matter which one we do first, but when you are graphing an equation, like if I give you this problem and then you have to graph it, the y-intercept should always come first. So it's honestly not a bad habit to get into, just to always do y-intercept first.
Okay.
That way you don't mix up like well, I know I need to do it first here, but I don't know about here, and then it gets all jumbled. I would say as a good rule of thumb, always do y-intercept first. Good question. One more question. I want one more. See ya. Yes.
I have issue, when I see the X and a number, I assume put it on the X line, that's why.
Understand.
That the X is there, and it's supposed to be the Y axis, but like, oh.
Yes. So that is something that you are not alone in. It is definitely a very easy thing to mix up. When you see the slope is right next to X, you think, oh, or the y-intercept is next to X. That's what you're saying? So, I am trying to think, what would the best way? I think just doing more practice is going to be the best thing that's going to help with that. Is just remembering that number at the end. That is the y-intercept. It goes on the y-axis. You could also think, here's something I just thought of. My x is over here with my slope.
Yeah, that's all I was just about to
My
say.
y, connect it like that. So I know, okay, my b, my last number, that goes with the y-axis. My slope is the only time that I start doing a run. I move over and I'm not just using the y-axis.
Yeah, so basically you're just doing the problem backwards.
Yeah, really, you're just doing it
Everything's
backwards. Pretty much. Yeah, that's a great way to think of it. Okay. Now, let's see. I wonder if I put this into like a real world situation, if it would make more sense. Would you guys like to see like where would we even use this in your life?
Yeah.
Okay.
Please do.
Let me show you, because this is actually something you can use, like if you want to save money up and figure out how long it'll take you to save up to a certain amount. This is so useful. So I'm going to pull out another piece of paper, and I'm going to show you where would you use this. Now, this isn't necessarily notes. I'm just showing you this for fun. It won't be something I test you over, so you don't have to write it down, but it might be something you use in real life. So, keeping that in mind, here's what we will do. I'm actually not going to use the graph paper because I want to create a bigger graph. Let's see. I need my thick black pens. So, let me think of a situation. Let's say I have a friend who has $200. That's all the money they have. So we'll say Sally has $200. Okay, that's her starting point. And let's say Sally is trying to save up to buy a new purse. Sally has $200. She wants a new purse. This purse, let's say it costs,
Look at the time.
it's a lot of money. It's a lot of money. Let's say she wants to buy a purse, and let's say this purse costs $5,000.
Wow, you didn't go to,
It's staying the same.
I know it.
not a Vera Bradley.
Yeah.
Look at her.
First cost
Yeah, my wife
$5,000,
is
then that would have been not paid, but not market, not.
Okay, so she's starting with only 200. That's all she's got. We're going to pretend that she's not paying for bills. She's not doing anything else. We're just going to think about what she has and how much she earns. So let's think. What does Sally do for a living?
Where's that gas station?
She works at a gas station. So let's see. What do we think an average gas station worker makes?
$17.
17 an hour, you think? So like that would be how much money each day? Take that times 8 hours.
100 and.
What's the dollar when you need it?
Right.
The reason why I'm saying is because I'm giving a reference because that's what I make.
What? There you go.
Yeah.
Okay, so let's say 17 times, let's say you work 8 hours a day.
Yeah, I do.
Okay, so that's before taxes.
That's $136.
$136 a day. So, let's see. I am going to, yeah, we'll use that. Let's make that an even 100 a day, just so this problem isn't as difficult to work with. But I'm happy to show you more complicated stuff. So she makes $100 a day.
But then you gotta factor out food and.
Right.
gas.
So we're going to pretend this is a perfect world where that doesn't even exist. So our starting point, 200, this is going to be like our y-intercept. This is where is it touching the beginning line. So let me draw a graph, and we're going to make a graph to show what her money savings looks like. And now since we're working with money, and we're going to pretend that she's not going negative or anything, we're only going to work with this part of the graph, not the full 4 quadrants, just this part. Okay, so this is our 0, and let's say, okay, she makes 100 a day, so I'm going to go 2 spaces, that's 100, that's 200, 300, 400, I'm not going to have enough space to get us to or 5,000.
You could do two, well.
Let's try something different.
Which works for you.
Hang on, let me wipe this out. And I'll use a different,
Smaller pen.
yeah, smaller pen. I just wanted to make it big so we could see it. So let's try this again. Instead, I'm going to label my days first. Okay, so,
And on average, you'll work 5 days a week.
yeah. Let's see. Maybe we go by weeks. I don't know. We're kind of doing this randomly. So I'm making a graph. Okay. So our y-axis is here, and this is measuring money. Okay, so our top amount is, we're at that 5,000. We'll start from there. So 5,000 is the high point, because that's her goal. She wants to make $5,000 so she can buy that purse. And I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, but if you do the little tick marks in the middle, that'll kind of actually help you get the
Yeah,
5,000.
it probably would. I'm going to divide this by 10. Okay, so we'll call this 4,000. We're going to skip some numbers. 3,000, 2,000, and I don't think that's totally dry yet. 1,000. Okay, my graph is not exactly perfect, so I'm sorry, guys. So that's 500. And actually, this is going to end up being my 0. Okay. Remember, I'm not testing you over this, okay? So if you're a little confused, it's okay. I'm a little confused too. So I'm going to make a new x-axis because I messed it up. Sorry. All right. So just pretend that doesn't exist. All right. So we're going to go by days, I suppose. And we'll start at $200. That's how much she started with. So my first point is going to be at about 200. Now we're going to guess because right in between 0 and 500, that's 250.
Yeah.
So
The graph would have been right if you would have kept going.
I should have. I know it. All right, so there is about my starting point, about 200. Now, if she makes 100 a day, let's say that 500 more would be at 5 days. So I guess we'll say 5 days, 10 days, 15 days, 20 days, 25, 30, 35, 40,
3 days will have for years.
45. Yeah, we'll see. 50.
That's how
Okay.
long it's gonna take days.
So, let's say she makes $100 a day. After 5 days, she has made $500 more dollars. So, we're jumping from 200 plus 500. Now we're at 700-ish. And we're here. Okay? We can kind of look at the slope of where our line is going to.
Trying to go up.
We're going up a few, over a few. And it looks like we're really going up about 2 and over 2-ish. Okay, so let's see. About, I'm going to use like a scissors.
This is because you're gonna pay other bills or anything, right?
Yes, so she basically living off somebody, but she saving her money.
Right.
You're gonna be homeless and
So if I were to be really specific and draw a line, I could continue it on and see how many days would it take for her to get that much money.
60.
And it would take, well, I don't know for sure, but let's do an equation. So sometimes drawing it out takes forever. You saw it, it's hard, especially when we're not working with nice clean numbers. But if I wanted to write an equation for this, $5,000 is the goal. So I'm going to write $5,000. That's equal to 200 is my starting. So that's my y-intercept. So plus 200. And then she makes $100 a day. So this is the rate of change. This is giving me my slope. 100, and I'm going to put x. If I solve this equation for x, it's going to tell me how many days it's going to take to get $5,000. So here's what I'm going to do. Minus 200 from both sides. And 5,000 minus 200, what is that?
480.
4,800, is that right?
Yep.
Equals 100x. Divide by 100.
48.
And we get
47.
48.
Oh, 48.
So it's only going to take her 48 days. If she works 7 days a week and doesn't have any bills, it's going to take her 48 days to get $5,000. Now, that is not realistic in the real world. I don't think I can save up that much in 48 days. It'd probably take me a very, very long time. But
It's possible.
you never know. If we wanted to, we can use equations like this to solve problems like that. This was not a great example, I'm going to be honest. Let's use more realistic numbers. So using y equals mx plus b, your m, your slope, is the rate of change. It's telling me how fast does this thing change that I'm measuring. Like, how much money am I making per day? How much do I make per hour? How much water fills up the swimming pool per hour, maybe. You're trying to see how long does it take to fill up a swimming pool. B is your starting point. What do you start with? Same thing when you're graphing. Oh my gosh. And Y is like your total or your goal.
The average.
Your total or your goal. Okay? So again, I'm not testing you over this, so don't freak out if you're like, what is going on? This is it's just a crazy day for me. So I want to think of another scenario though, because I want this to actually be useful to you guys.
Gas.
Gas. Okay, so what's a scenario with like gas?
you gotta, like, with gas, you gotta know your gas tank.
Yes.
How many gallons of, how much gallons would your tank hold? And how much money does it take for you to fill that gas tank?
How much to fill it up?
Well, depends what
Let's
days you got it.
see. Yeah, I guess it.
And it also depends on the prices of the gas. 'Cause
Right.
It changes.
Right, man, that's a whole problem. That would take us a minute.
So that's an everyday life thing?
It is an everyday life thing.
And you know.
Well, this wouldn't be this type of equation, but we could do that. Let's say gas. Last time I saw gas, the price was like
$3.89.
$3.89?
$3.39.
$3.39. Okay, let's say it's $3.39. Let's say my tank holds 14 gallons. That's a big tank. This is a big tank. Most people's gas tanks are not that big.
How many gallons now?
Okay, so I want to know how much money is it going to cost to fill up my tank? How would I solve this? This is a different type of problem.
You gotta know if it's a half tank or if you're on empty or.
Yeah.
We're on empty.
So you would take 14 times $3.95.
Okay, let's see. So 14 gallons, and then it's $3.39 a gallon.
$3.39.
So, yeah, we would take that 14 times $3.39, and that gives us $47.
Oh,
That's about how much it cost me.
So you got an SUV right there. No,
I do.
no,
I
not
do.
SUV. You got a, yeah, because a Suburban is like 100 and something.
I got one of those cars that's like, oh man, I can't draw a
On
car.
average, well, no, you got a sedan. Because that's about how much it takes to fill my car up, and I have a Chrysler 200.
so minivan, don't you?
Yeah. That look good?
I mean,
Yeah.
You got the Scooby-Doo.
Oh, God. Okay, guys, yeah, we're off track. I'm sorry. Okay. Lord.
Today, so.
I know, we're having too much fun. Let's get back to it. I want to run through writing an equation like one more time, and then I'm going to see if y'all can do it on your own. So, where were we? What did we just do? We were here. Not even in the same notebook. Yeah. Fourth period. You got a fourth period class?
You?
No.
No.
You guys are my fourth period. I get you all day.
Fourth period starts at 2:05.
Yep. Welcome to fourth period. Oh, I guess I should give you a break.
Yesterday we were done by this time.
Y'all need a break? Y'all want a little break? Okay, I'll give you a break. All right, so I just gave everybody a copy that looks like this. There are 4 lines on this copy. Your task is to find the y-intercept of each line, count the slope of each line, and see if you can write the equation. So I will pause the video again, and I'm going to let you guys try working on that. Okay, so we have 4 lines, and we're going to write 4 equations. We're going to start with this first one. Let's get it clear first. Okay, so what's the first step?
Find the y-intercept.
Find the y-intercept. Where does this line touch the y-axis?
+5.
At 5. So, my y-intercept is 5. My y-intercept is also b in my equation, so I'm going to keep that in mind. B is 5. What do I need to do next?
Find the slope.
We want to find the slope. So we want to make sure we start on a point that has another point to the right of it. So we're starting from the left. So we'll start here. Now to get from this point to the next, do I go up or down? Down. I go down 1, 2, 3. So what is my rise?
-3.
-3. And my run, 1, 2, 3 again. So my run
+3.
is +3 to the right. And that's my slope. Or my M. So I'm going to write my equation and leave spaces for the numbers I just found. We've got y equals,
-3 over +3.
good, -3 over +3,
X equal +5.
x, not equal,
Oh, +5.
yes, plus 5. That is our equation. All right. And right above it, I'm just going to write that y equals mx plus b as a reminder. That's where these numbers came from. Our slope and our y-intercept. The m and the b. And this is our answer. Very nice. Okay, did anybody get something different, or is anybody unsure how we got here? We all get this one? Nice. Very nice. Okay, are we ready to look at the next one? Okay, I see a few still copying it down, so I'll wait just a minute. Okay. Let's look at the next line. So, what is my y-intercept? 1. That's where my line is touching my y-axis. So, my y-intercept, or my b, is 1. Okay? How do I find my slope?
Go up 4,
Go up, let's see, 1, 2,
3.
just 3. So we'll go up 3. So that's my rise. We went up 3.
And 1 is your
And my run, how many spaces over?
1, 2.
2. 1, 2. So my run is 2. Okay. And that's my slope. Or my m. So if I want to write the equation y equals mx plus b, y equals, what's m?
3 over 2.
3 over 2. What comes next?
X.
X.
1.
Good. Plus 1. Very nice. There we go. That's our next equation. Pretty good, guys. Okay. Any questions on this one?
Now,
Okay, wonderful, wonderful. See some of us still copying. I'll give us a minute or two. Okay. Slowly move it. All right, let's look at the next one now. Okay, what's my y-intercept? -3. That's where I touch the y-axis. So my y-intercept, or my b, is -3. Okay? Now how do I find my slope?
Go up 6.
So we could count it from here, going up 6 and over 3.
No,
Okay?
you gotta stay negative, so you wanna go all the way.
So let's maybe start from this point to the left so that we don't mix our signs up. So starting over here, do I go up to my next point or down?
Down.
Down. So I go 1, 2, 3, 4, 5, 6. And now I'm in line with my next point. So what's my rise?
-6.
Good. My rise is -6. Why is it negative?
Because you go down.
Because we went down from one point to the other. We went down. Okay,
And your
so
run is gonna be
1, 2, 3. Yep, our run is 3. Perfect.
When y equals negative 6 over 3,
Mm-hmm.
x is negative 3.
So here, let's do this. Y equals my m, my slope,
Negative
negative 6 over 3,
x
x
negative 3.
minus 3. Good. Perfect. That is my third equation. Okay, looks good, guys. Right. Any questions on this one? What if you would have counted from the lower point or from the point to the right?
Put in a positive number.
So let's just play with that scenario. Let's say I decided to count from this point and I went up 6, okay? And then I went to the left 3.
Positive 6 over negative.
Yeah, I mean that's the same number. It will still work. It's just keeping track of when is it positive, when is it negative. So sometimes what a lot of students I see end up doing is not worrying about the negative until the very end. They'll just count the rise and the run, get the numbers, and then say, is my line pointing up to make it positive? Or is my line pointing down and it's negative? This line is pointing down, so it's negative. We could have done it the other way. It's really preference, whatever gets you less mixed up. Okay. Other questions on that one? Okay, let's look at the very last one now.
Two ways to solve this.
Yeah, we have a few ways to solve this one. Let's start with our y-intercept. What is it? 1. My line touches the y-axis at 1. 1. Okay. And we could have counted the slope in a few ways.
I did the negative one.
Starting from here? Okay, let's start from there. What is my rise to get to the next point?
1.
Just 1. We go up 1. So my rise is 1. And over 3. Over 1, 2, 3. That's my run. So my slope is 1 over 3. Okay. Okay, so let's write that equation now. Y equals,
1 over 3,
good, 1 over 3,
x,
x,
1.
not just 1, what goes in between? Yes, plus 1. Y equals 1/3 x plus 1. Beautiful. Pretty nice. That's our equation. Okay. Not too horrible. Not too horrible. Okay. So that is our fourth problem. I'll leave that up for a moment if anyone is still kind of copying that down. But I think I'm going to go ahead and give you an exit ticket. It'll just be one problem today. And you're welcome to wait for copies if you like. But when you get started making that, okay. Can I move this, or does anyone still need it? I'm gonna move it. Okay, so I am going to make you an exit ticket. Let's see. Day 10 exit ticket. Okay. And I want you to write the equation of the line below. Okay. And I want the graph to be a little bit bigger. So I am going to draw a graph this time. Go for it, girl. You go for it. And I will make copies of this for everyone. Okay. 1, 2, 3, 4, 5. Okay. All right. And I will connect the dots and make copies. And I'm going to leave you a little 1, the y-intercept, 2, and the slope. Okay, so just something to help. Let me say this will be due Friday, April 11th. And I'll write a spot for you to put your name on it. All right, that is all. I will make copies and then you guys are free to go.